Welcome to the Tech Egg. Don't get scrambled. Enjoy the video.
You begin by importing your video and confirming the camera frame rate so timestamps are accurate. Once the file is loaded, place a scale marker on a known length and define the origin and axes to convert pixels to meters. This calibration is critical because it links video coordinates to real units. Next, create a new point mass track and place the first marker on the object. This first actionable step starts your data collection and ensures consistent tracking. Now you proceed through the middle of the process. Advance frame by frame and place or correct markers so the object center remains accurate. Use the auto tracker for steady motion, but manually correct when occlusion or motion blur occurs because automated fits can drift. Make sure to enable subpixel interpolation and appropriate smoothing to reduce noise, and define measurement regions or constraints if the motion is constrained. This yields more reliable position and velocity data for later analysis. Finish by exporting calibrated position and velocity data to CSV and clearly label units so analysis is reproducible. Then fit suitable models, linear for constant velocity, parabolic for constant acceleration, and compute uncertainties to evaluate fit quality. Once done, inspect residuals for systematic error. If results look wrong, recheck your scale length and frame rate, ensure markers remained consistent across frames, and rerun tracking on problematic segments. This single troubleshooting step.
Thanks for watching. Consider subscribing if I helped unscramble your problems.